there, welcome to www.highschoolmaths.co.uk. Today we're going to be looking at how you multiply and divide fractions. We're going to look at proper fractions and improper or mixed fractions. So we're going to start off looking at multiplying, and we've got a really simple rule for multiplying, which is top times top, bottom times bottom, or numerator times numerator, and denominator times denominator. So we're going to look at these two examples here, nice straightforward ones to start off with. So we've got a quarter times 2/5. Take the top number, top times the top, 1 times 2 is 2. On the bottom, we've got 4 times 5. 4 times 5 is 20, so we end up with 2 over 20. Now we've got to look to see if this fraction simplifies, and it does. They're both in the 2 times table, so we divide the top by 2. 2 divided by 2 is 1, and the bottom by 2 to give us 1 over 10 as our final simplified fraction. Same idea with the second one, so we're doing top times top, 3 2s are 6, and then the bottom times the bottom, 5 times 3 is 15. And we end up with two numbers that are both in the 3 times table. So here we can divide by 3 on top and bottom to get 2 over 5. And there's actually a kind of shortcut you can do when you're multiplying fractions, but only when you're multiplying fractions. You can actually cancel a number on the top of one of the fractions, so not one of the numerators with one of the denominators on one of the other fractions. So if we look here, what we could have done alternatively, rather than going through this process of multiplying and then simplifying, we can simplify first, because if we look here, we can see this number and this number are both in the 2 times table. So if we half both, or if we divide these numbers both by 2, we get 1 and 2. And then if we go through the process of top times top, 1 times 1 is 1, 2 times 5 is 10, and we still end up with a 1 over 10. So with multiplying, you've got a choice sometimes, providing that there's something on top and something on bottom that can cancel down. If you look at the second example here, you'll notice there's a 3 on top. If 3 is the numerator of the first fraction, so we can divide here and here by 3. Divide that by 3 and you get 1. Divide that by 3 and you get 1. And the key thing there is one of the numbers has got to be a numerator and one's got to be a denominator. So you've got to cancel something on top with something on bottom. And if we go through that process again, top times top, 1 times 2 is 2, and 5 times 1 is 5. So we end up with 2 over 5, as we did. We went through it the other way. So sometimes that may help if you get really, really big numbers with your fractions. If the numbers are small, then it's kind of 6 1/2. It really doesn't make that much difference. But if you get really big numbers that are difficult to multiply, and you're talking about a non-calculator question, then it can help sometimes to simplify first. So let's have a look at another example. This time we're jumping onto mixed fractions. Same idea. So we're just going to go through the same process, but the rule can't apply yet because these are mixed fractions. So what we've got to do is convert them into top heavy or improper fractions. So to do that, we multiply the whole number part, the 3, by the denominator. So 3 times 4 is 12. Then add it onto the top, which is 13 over 4. The first fraction, 2 3s are 6. Add it onto the top would give us 8 over 3. Denominators are staying the same. Okay, now we can apply our rules. Now at this stage, I'm thinking top times top, 13 times 8. That's not the easiest multiplication to do. Is there anything I can do to make that a little bit easier for myself? And there is. If I look here, this number and this number are both in the 4 times table. So if I divide this by 4, I get 2. If I divide this by 4, I get 1. And that makes it a lot easier because 13 times 2 is 26. And 1 times 3 is 3. And we can convert this back into a mixed fraction. So we're looking for how many 3's go in to 26. So 3 8's would be 24 with a remainder of 2. So 8 and 2/3 for our final answer. Let's look at the second one. So same thing again, we're going to convert them to top heavy first. 1 times 5 is 5. Add that onto the top would give us 6 over 5 times 3 3s are 9. Add onto the top would be 11 over 3. This time, if we look across, we can see we've got a 6 here and a 3 here. We can cancel them down. They're both in the 3 times table. So dividing this by 3, how many 3's go into 6? 2. How many 3's go into 3? 1. And then we can go through our top times top and bottom times bottom process. So 2 times 11, 22. 5 times 1 5. And again, we end up with top heavy answer here. So how many 5s go into 22? That would be a 4 with a remainder of 2. So 4 and 2/5. Okay, so that's how you multiply both proper and improper fractions. So let's have a look at dividing now. Dividing is actually really, really similar to multiplying because obviously they're inverse operations, so they are linked. So if we look at dividing, there's just an additional step that you have to take at the very beginning. So the kind of rule, if you want to remember, one is you flip the second fraction and change to a times. So we keep the first fraction the same, so the quarter stays 1/4. We change to times and we flip the second fraction upside down. Okay, and once we've got to that stage, we're just doing exactly what we just did for the multiplying. So top times top, bottom times bottom. And fairly easy numbers here, so we don't have to check for anything that can cancel down. 1 times 5 is 5, 4 times 2 is 8, and we get 5/8. And that's a proper fraction, can't simplify that anymore, so that's our final answer. Let's look at this one. So same rule, we take the first fraction and just carry that down, we change to times, and we flip the second upside down. Top times top, 3 times 3 is 9, bottom times bottom, 5 times 2 is 10, and we end up with 9/10. So nice, easy, straightforward rule, and we can apply the same kind of rules we had for mixed fractions. So we make it top heavy first, 2 4s are 8, add on to the top is 11, so we get 11/4. Divided by, and it's still divided by, we're not doing anything with the dividing yet. 3 times 2 is 6, add on to the top is 7/2. Okay, now we're going to deal with the dividing part. So we're going to keep the first fraction exactly the same. We're going to change to times, and we're going to invert or flip the second fraction to 2/7. Now, at this stage, the numbers aren't too bad, but I have noticed that actually we've got a 2 and a 4 here. So if I wanted to, I'm going to cancel them down. They're both in the 2 times table. How many 2s in 2? 1. How many 2s in 4? 2. And it just makes things a little bit easier at this stage. 11 times 1 is 11, over 2 times 7 is 14, and we end up with 11/14 as our final answer. Okay, and there's lots of different varieties of questions where this can be used in a context. So here, for example, we've got a length of ribbon. It's 3 1/5 meters long. A cake requires 3/4 of a meter of ribbon. How many cakes can the ribbon decorate? So we've got to think about what it's actually asking us here. There's 4 possible choices with fractions operations. You're adding, subtracting, multiplying, or dividing. Here, we want to find out how many of the 3/4 meter ribbons can we get from the 3 1/5 meter that we have to start off with. And if you're looking to see how many of something fits in something else, you're talking about division. So we're going to take the 3 1/5 meters that we have, and we're going to divide that by the 3/4 we need for each cake. And once we've gone through that process, we're just back into the kind of routine steps for dividing. So we convert this to a top heavy fraction. 3 5s are 15. Add on to the top would be 16/5, divided by 3/4. We don't need to do anything at 3/4, that's fine as it is. We're then going to deal with the dividing step. So we're going to keep the first fraction the same, change to times, and flip the second fraction upside down, or invert it. Here, we're looking to see, does anything cancel down? Not really. So there's no common factor we can take out across the fractions here. So we're going to have to deal with this multiplying. So 16 times 4. So for times by 4, times by 2, times by 2. So 32, then 64 over 5 times 3, which is 15. And then it is a top heavy or improper fractions. So we want to simplify that into a mixed fraction. How many 15s fit into 64? Well, that would be 4. 4 15s are 60, with a remainder of 4. So 4 and 4 15ths. So how many cakes can the ribbon decorate? Well, the ribbon technically could decorate 4 and 4 15ths of a cake, but you can't really decorate a part of a cake. So the ribbon could decorate 4 cakes. Okay, so we're looking for how many full cakes we could use for that ribbon, or use that ribbon for. So it would be 4 full cakes, and we'd have a little bit left over at the end, but not enough to do 5 full cakes. Okay, so that's your multiplying and dividing mixed fractions. Those are your steps. Quite different from the adding and subtracting. If you've not checked out that video, please check that out. But two different processes there, and once you get into the habit of it, it really is quite straightforward. No matter the numbers that come up, you will be able to deal with it. So keep watching them over again, practice it as much as you can. And for other maths, any other maths videos and resources, go and visit www.highschoolmaths.co.uk. If you like the video, don't forget to click that like button. Don't forget to click that like button and subscribe. And please remember and share this video. Thanks for watching. Have a mathemagical day.